Welcome to Diamond Solutions for Mathematics. Today we are discussing applications of differentials, rate of change of quantities. Here is a question related to rate of change of quantities. The volume of a spherical balloon is increasing at the rate of 25 cc cubic centimeter per second. What is the rate of change of its surface area at the instant when its radius is 5 centimeter? When the radius becomes 5 centimeter, what is the rate of change of its surface area of that spherical balloon? That is the question. Here we have to consider three variable scores, that is radius, volume and surface area. Let R radius, B volume of the spherical balloon and S the surface area of the spherical balloon are the radius of the spherical balloon. B respectively the radius, volume and the surface area of the sphere at time t. T is the parameter for 3. Therefore, we are considering V equals volume equals 4 by 3 pi r cubed for a spherical balloon. And surface area of the spherical balloon and S equals 4 pi r squared. These two are we can consider to be two functions. Rate of change of volume with respect to T equals dr by dt. That is given here 25 cc per second. That is rate of change of volume with respect to T dr by dt equals plus 25. Why? Because the volume of a spherical balloon is increasing. Therefore plus 25. If it is decreasing, then we can put minus 25. Here plus 25 for increasing at the rate of 25 cc per second. Therefore, rate of change of volume. What is volume? 4 by 3 pi r cubed is the function related to volume. Therefore, d by dt of 4 by 3 pi r cubed equals 25. Why? Because the rate of change of volume with respect to T equals dr by dt plus 25. Therefore, d by dt of 4 by 3 pi r cubed equals 25. That is r cubed. Here 4 pi r squared dr by dt. That is the differential coefficient of r cubed here. Therefore, 4 pi r squared dr by dt equals 25. Therefore, dr by dt equals 25 by 4 pi r squared. That is rate of change of r with respect to t is 25 by 4 pi r squared. That is rate of change of surface area with respect to T equals ds by dt. Rate of change of surface area of the sphere, spherical balloon, is ds by dt. That is d by dt of S is considered to be 4 pi r squared is the function related to surface area of a sphere. Therefore, ds by dt equals d by dt of 4 pi r squared. 4 pi r squared equals 8 pi r dr by dt. 8 pi r dr by dt. That is the differential of 4 pi r squared. Dr by dt is implicit. Therefore, 8 pi r into dr by dt we already defined it here as 25 by 4 pi r squared. Therefore, instead of dr by dt, we can put 8 pi r into 25 by 4 pi r squared instead of dr by dt. That is 8 pi r into 25 by 4 pi r squared. That when simplified, 4, 8 goes to 2, pi r and pi r squared makes 1 r remains here. Therefore, 2 into 25, 50. 50 by r, that is equal to 50 by r is the resulting answer of rate of change of surface area with respect to t. ds by dt is defined as 50 by r. That is rate of change of surface area when r equals 5 centimeter. That is the question here. Find the rate of change of its surface area at the instant when its radius is 5 centimeter. That is, when radius of the sphere is 5 centimeter, what is the rate of change of surface area? Therefore, rate of change of surface area when r equals 5 centimeter equals 50 by r. Instead of r, we can put 5. That is 50 by 5. That is 10 centimeters squared per second. Why? Because area. Therefore, 10 square centimeter per second is the resulting answer of rate of change of surface area when r equals 5 centimeter. That is the final question they are asking. And our answer comes to defined as 10 centimeters square per second. Subscribe Diamond Solutions for easy and tough questions of mathematics.